is Lab 18, Example 3. We have the quadratic equation 2x squared minus 10x minus 5 is equal to 0. We want to use the discriminant to determine the type of solutions that this quadratic equation will give, and then we want to actually determine the solutions and write them in simplest form. So, in example 1, I explained what the discriminant is and how it comes from the quadratic formula, and what the discriminant can tell us about how many roots we have and what kind of roots we have. So, our discriminant is b squared minus 4ac, so we're just going to jump right in and find that. So our discriminant d is equal to b squared minus 4ac. Our b is negative 10, so we have negative 10 squared minus 4 times a, which is 2, times c, which is negative 5. So if we plug this all into a calculator, we get that d is equal to 140. So 140 is greater than 0. So if we go back to our little sheet here, if our discriminant is greater than 0, we have two real roots because it touches the x-axis twice, so we also have two x-intercepts. So because our discriminant is 140, which is greater than 0, we know that we have two real roots. So now that we know that it's going to have two real roots, we're going to actually find what those roots are by using the quadratic formula. So quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac, this is our discriminant, divided by 2a. So plugging in, we have negative b. Negative of negative 10 is positive 10, so we have positive 10 plus minus the square root of b squared, so negative 10 squared minus 4 times a, which is 2, times c, which is negative 5. Again, this is exactly what we did for our discriminant, divided by 2 times our a, which is 2. So since we already know what the inside of the square root is, it's our discriminant, which is 140. We're going to plug that in. This is 10 plus minus the square root of 140 divided by 2 times 2, which is 4. So now what we want to do is simplify this square root a little bit. If you break 140 down into its prime factors, you'll find that the only perfect square that you can get out of it is 2 squared, which is 4. And if you divide 140 by 4, you get 35 times 4. So we're just going to break it down like that. So 140 is the same thing as 4 times 35, essentially. And the reason we broke it down this way is because 4 is a perfect square. It's 2 times 2. So we can essentially pull it out to the front, the 2. We can pull out the 2 to the front of the square root. So this is 10 plus minus 2 times the square root of 35 divided by 4. So now that we have it in this format, we're going to split it up into our plus minus. So we're going to have two real solutions, which is what we expected. So we have 10 plus 2 square root of 35 divided by 4, and we have 10 minus 2 square root of 35 divided by 4. So we can also further separate this because we have our numerator. We can separate it into 10 divided by 4 plus 2 times 35, square root of 35 divided by 4, and we can do the same thing for this one. This is the same thing as 10 divided by 4 minus 2 times the square root of 35 divided by 4. So now all that's left to do is to simplify these fractions. 10 divided by 4 can be simplified by taking 2 out of both of them, which would give us 5 halves. And we can take out 2 from both 2 square root of 35 and 4, which just leaves us with square root of 35 over 2. So this is one solution. And doing the same treatment to this solution right here, 10 over 4 is the same thing as 5 squared. Taking out the 2, we get square root of 35 over 2. So these are our two roots right here.